tag a single brethren below because today we'll be looking at singular matrices.
Since you leave me, I am alone. I am like a dog without a bone. Girl, I don't want to be alone.
Matrices! A matrix is made up of rows and columns, and its size is given by the number of rows followed by the number of columns. So this matrix on the screen would be a 2 by 3 matrix because there are 2 rows followed by 3 columns. This would be a 2 by 2 matrix because there are 2 rows followed by 2 columns. Since the rows and columns are the same, it's an example of a square matrix. To find the determinant, we are going to take the product of the first diagonal, then subtract the product of the second diagonal. So for this matrix M, we would say A by D minus B by C. If the determinant is 0, we would call it a singular matrix. And how I like to remember this is you have 0 birds, so you're single. Tag somebody who have 0 birds. Let's look at an example now. Let's say we have this matrix A whose elements are 1, 2, 3, and 6. So to find the determinant, we would say 1 by 6, that's the first diagonal, minus 2 by 3, that's the second diagonal. 1 by 6 is 6, 2 by 3 is 6, 6 minus 6 is 0, so matrix A is an example of a singular matrix. You should also know that you cannot find the inverse for singular matrices because you can't divide by 0. If the determinant is not 0, then we call it a non-singular matrix. So here is a question for you to try. Find the determinant and drop your answer in the chat below. Alright, so let's resume. We have matrix R and its elements are 5, 8, 3, and 5. So you'd multiply 5 by 5, that's the first diagonal, minus the second diagonal, which would be 8 by 3. 5 by 5 is 25, 8 by 3 is 24, so we end up with 25 minus 24. So matrix R has a determinant of 1, and notice R for Rajiv, because my lessons are the one for you. So drop a fire emoji if you learned something new, and until then, see you guys in the next video.